Hello Internet! In this video I'm going to talk about 3D printing and motorcycles. I have had a 3D printer for many years and I have been printing many parts with the printer. And moreover, I have been printing some parts to my motorcycles. There are many places in the motorcycle and motorcycling where you can utilize 3D printed parts and not necessarily to buy everything from the internet or somewhere else. There's one specific problem with this bike. I'm going to do something with the 3D printer. The problem with the bike is that there's quite large opening on the both sides of the bike. And from the opening you can see the back wheel. And the problem with the opening is that when you ride in rainy conditions, the back wheel throws quite a lot of water and dirt through that opening to your legs, back to the boot and back to the pants. So everything is quite dirty after a while, even though this bike has full cover everywhere else by the fairings. So this place is what I'm definitely going to do something with the 3D printer, and let's do it. 3D printing or additive manufacturing is the construction of a three-dimensional object from a digital 3D model. I create the model by a computer application which I will show in a minute. Then the file from the model needs to get to the 3D printer. I use the memory card. This printer will take in the filament, which is this kind of plastic strand. The printer head is very hot and it melts the filament continuously. Then the printer head is moving over the parts bed and melts the filament layer by layer together. The printer head moves according to the design file, which is sliced into layers. This whole 3D printing method is very fast. I can design a part I need in a few moments, then print a model in minutes. Of course, if the part is large, I have to wait for the print even some hours to finish. This kind of production is cheap, and typically parts cost me some cents or maximum of a couple of euros. And if the part breaks, I can print a new one easily from an old design file. Moreover, I can do multiple versions of the part. Often the design needs to be corrected somehow when the part is in place, so printing the new version is very fast. So my trash bin is full of versions of the different parts I designed, but fortunately the plastic recycles well. There are restrictions on how large a part I can do at once, but of course larger parts can be formed from the smaller ones. By the way, if you like this video, give a big thumbs and subscribe to this channel, and click a bell icon to get notifications of the new videos. Okay, when I start to create the 3D part, first I need to measure the part somehow or create the model. In this particular case, because the part will be flat, I will create this kind of cardboard model by cutting it with the scissors and try to fit it in its place. And after a while I have a perfect model, cardboard model of the part. Then I just adjust the cardboard model so that it fits in its place, like that. Perfect. And then I just continue to my scanner, and I will scan this cardboard model as a file which I can manipulate in my computer. This I will show in a minute. First, I put the cardboard model on the scanner. The scanner scans the cardboard and makes it to electrical form, which I can manipulate with the software. I save the scanned file as a PNG file. Then I can load that file into the Fusion 360 software, the computer-aided design software. First, when I load the file, I have to calibrate the size. I have measured the distance between certain points of the cardboard, and with the calibration command I can make the real size component. Then I need to trace the outer edge of the cardboard with the line command. After tracing, I will do some basic modifications to it. I create the hole for looking at the rear brake fluid level in the reservoir. And I decide the thickness of the part. Then I can save and export the file in the STL format. This is for the next software, which is the slicer. The slicer takes the model and makes the file that the 3D printer understands. In this software, I make adjustments to the printing process. For example, how many solid layers I want to have, and also temperatures and other parameters. Then I can save the file to a memory card. Okay, now I have the file which I made with this 3D Simplify software, and the file which represents the part is in the form that this printer can understand, and it can start to make the part based on my design. Let's continue. Okay, now I put in this memory card, and then I say to the printer that start to print my work. It's the lowest one, and then I say print. Okay, now the printer has done its job, and let's see what's the result. I open this chamber here and take the print out. Let's see how it fits in its place. As you can see, it fits perfectly there. The opening is covered totally, and there's no possibility for mud and water come out from that opening. Finishing is quite pleasant. It's kind of matte sheen there, but also because it's kind of normal plastic, I can do some paint or some other type of coating to it. That's not a problem with these 3D printed parts. Okay folks, now I have made the first piece, and I need to do the other side as well. Then I need to ride the bike and see if my design is fit for the purpose. Maybe I need to change something. For example, how can I easily take covers away when cleaning the bike more thoroughly. But the remodeling and printing of the parts over and over are easy. And coating the pieces, for example with carbon fiber tape, would be interesting to try. I have made many parts design, and I'm looking for the possibilities to sell the files on my webpage. The design file price would be low depending on how complicated the part is. Like this cover here is maybe 10 to 15 euros. The commercial cover kit starts at maybe 150 euros, so that's the difference. Of course the kit has everything to fix the cover in its place, but still. Moreover, I like designing and printing the parts myself so much that it is pure joy to do it. So that's about it. See you in the next video.